Happy Easter! The transition begins. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you'd like to leave a comment or question, please do so down below. We'd be happy to reply. And if you want to make a contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Evolution Moto, Our Predicament, Clay Goose, IJ Coach Nate, and E. Slate. All these folks have contributed before, and some are longtime contributors. Your contributions are always welcome. And with that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, nothing is happening. Transition is happening for sure. The South Pacific, a series of gales are traversing the South Pacific, one with seas about 39 feet and the other in the 30-foot range. North Atlantic, things pretty calm as well, maybe some scattered 19-foot seas. South Atlantic, not a whole lot going on. Indian Ocean, gale with 29-foot seas in the South Central Indian Ocean, another one with 29-foot seas south of Australia. So the pattern now definitely looks like it is fully shifted to the south. But first off, let's take a look at current conditions. We're going to look at the buoys. We're going to start up off of North Oregon, the Columbia River area, the Grays Harbor buoy, number 036. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period energy, 0.0 feet of energy there, down to pure wind swell, and there's about 9/10 of a foot of energy there, but most of everything looks to be scattered between about the 11 second period range and the 7 second period range, everything in 1.5 to 2 feet. Let's see how the algorithm does at teasing out what's going on. Primary swell, 4.3 feet at 9.6 seconds from 289 degrees. Theoretically, that would make surf at your generic beach break at about 4.2 feet. And the chop height, 2.4 feet. Yeah, so that anything more than about 2.5 feet is pretty choppy. So pure wind swell, not unexpected. Next up, we go down to Northern California, the Point Reyes buoy, 029 off of Point Reyes near the Golden Gate Bridge. Same sort of profile, all of it really just looking like wind swell, but a bit more energy, 3.6, 3.8 feet in individual period bands here at 9.9, 9.1 seconds. A little bit of tease is something out at 25 seconds, but that could just be more than likely is just a buoy anomaly, but you never know. All right, let's see what we got here. Primary swell, 7.7 feet at 9.6 seconds from 323 degrees. So again, pure just northwest wind swell. Surf height, theoretically 7.4 feet, but a lot of this, because of the steep angle, gets blocked south of Point Reyes. So you know, maybe 2/3 of that is actually transitioning into rideable swell in the San Francisco Bay Area. And you see no secondary swell. Then we go down to Southern California, the Point Loma South buoy, 191 there. That's off of San Diego. Same sort of deal. We're looking at the profile here. You don't see really any wind swell because it's all blocked by the Channel Islands, but we see a little bump of energy here at 14.3 seconds. One can assume that is likely southern hemiswell. Let's see what we have here. 1.4 feet at 13.8 seconds from 228 degrees. That angle, I mean, so a lot of people, let's talk about angle at the buoys. I mean, no matter how sensitive they are, the angle is often not right. Do not use use the angle as a general idea. Is it coming from the hard north, the hard south, but don't do it specifically. The only way to really know the true swell angle, especially when it comes to trying to manage swell shadows and things like that, is you got to calculate the great circle path from the center of the fetch area to your beach. Anyway, 228 degrees, so some sort of background New Zealand swell. Surf height from that about 2 feet. Yeah, there's some waves. I mean, there was actually maybe some chest high peaks at select breaks this morning. And then a little bit of wind swell, 1 feet at 10.3 seconds mixed in, just the local wind swell sort of situation. And then finally, the north shore of Oahu, Waimea Bay buoy number 106. We have this, again, it looks like mainly just wind swell in, 1.5 feet generally across a bunch of period bands between 7 and 11 seconds, something like that. Primary swell, 3.7 feet at 9.5 seconds from 210 degrees. Again, that angle seems highly suspicious, but 3.5 foot surf. Yeah, it looked like it was about waist high, something like that. No secondary swell. So, right now, North Pacific appears to be going to sleep. We're waiting for the Southern Hemi to really start. Whatever might already be in the water from the Southern Hemi, we're waiting for that to move in to our local breaks. All right, so let's go make a quick review of what has been going on in the various oceans from a significant wave height perspective over the past 7 days since our last video. So here we are, Sunday, April 13th. A little bit of a gale, 20-foot seas was off Japan, another 19-foot seas up in the Gulf of Alaska. That built to about 23, but no meaningful swell resulted from that. Then there was this gale that developed north of Hawaii, producing initially, if you saw the models, it was, if I recall, 28 feet or something, maybe even higher than that, aimed at Hawaii. But it is the 00-hour hindcast, what actually formed, and that's what matters. And you see 19-foot seas, the 20-foot seas up here, pretty much not meaningful. You see the swell front eventually impacted Hawaii on Friday a couple days ago. And there was rideable surf. It was fun. I got a report from one of our viewers, said he had a good time at a couple of spots there on the North Shore. But that pretty much maybe is the last one of the season. We'll see when we get to the actual forecast. But here we are today, 18Z. Nothing other than that. So no swell in the water heading towards Hawaii or the U.S. West Coast. Then we go to the Southern Hemi, 12Z on Sunday, 13th of April. A gale developed south of New Zealand with 36.9 foot seas right there at the highest seas over this entire domain. There are the coordinates of it. They sync up exactly with that fetch. Wind speeds, max wind 61.9 knots at effectively the same position. So seas probably should have blown up a little bit more, 38 feet. At 18Z, 39 feet. That was on Sunday evening a week ago. By Monday, it was starting to fade, 37-foot seas, 35-foot seas, and it was all but gone. Swell from that system is in the water, pushing northbound into California and Hawaii. I think Hawaii first, and then we'll get into that in the forecast. A secondary gale developed right behind that with 28, 29-foot seas and two little lobes here in the upper reaches of the central South Pacific on Wednesday, the 16th of April. That produced a little bit. Then another system. Now, this one tracking pretty much due west to east started with, here we go, 38-foot seas on Wednesday, the 16th of April, made its way across the Pacific and then faded out. Another one behind that on Friday, the 18th of April, faded a little bit, but then it redeveloped today, not hugely so, but with 30-foot seas. Do I have one more frame here? There we go, 31-foot seas and aimed more to the northeast. So a series of 1, 2, 3, maybe 4 swells of some degree, none of them huge, but all of them pushing some degree of energy off to the northeast. Sideband energy mostly for Hawaii. I mean, for Hawaii to really get good swell, the low pressure or the gale would have to push up to the northeast here, hugging the coast of New Zealand. That's the optimal situation. California, just because it has a broader swell window here, is more able to capture sideband energy, even from these systems that go more or less due east. Not a lot of size. Top spots, Southern California probably do the best. Then to the North Atlantic, we're going back again to Sunday, the 13th of April, plowing through this little bit of a, I'll call it a low pressure system with 18-foot seas developed on Tuesday into Wednesday off the northeast U.S. coast and produced some energy pushing into Europe. But the machine, oh, look at that. I didn't even see that. On late Friday, 25-foot seas aimed at in here to France and Portugal. Certainly swell from that is impacting, well, probably on its way down by now, because here we are Sunday, if not wrapping up, and that was the end of that. South Atlantic, here we are Sunday, a week ago, 13th of April. Gale developed with 35-foot seas. In the South Africa swell window, sideband energy is probably already hit and gone. Yes, you see the swell front pushing in on like Wednesday, Thursday sort of time frame. And then some secondary energy there off the coast as well. Looks like a local gale aimed with fetch 22-foot seas aimed at Southeast Africa. That was on Friday into Saturday. And then nothing else in the greater deep South Pacific or South Atlantic as of right now. And then finally, the Indian Ocean, a gale, 26-foot seas developed on Sunday, 13th of April, aimed at South Australia in the Bali area. Another little system tried to push into the central South Indian Ocean, but it didn't really do a lot. You see swell from it from earlier in its life, working its way north. That is poised. Let's get right back there. Poised to push into West Australia today and energy up into Bali and the Mentawai Islands probably 2 days later. Based on what we've seen, it certainly looks like the balance of energies in the South Pacific. So we are going to go into our deep dive portion of the forecast and therefore accordingly focus on the South Pacific. We're looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough in the southern hemi, where that would be a push in the jet to the north, just like there. That helps create a clockwise flow aloft, which is the hallmark of low pressure in the southern hemi, opposite of the northern hemi. And that low pressure also manifests itself down at the surface. Low pressure is deep enough, generates winds on the ocean surfaces, winds generate seas. As the seas radiate away from the fetch area, the lesser period elements get groomed out, exposing the longer period swell elements. And of course, swell, when it reaches your beach, turns into surf. So we do have a trough here in the Southeast Pacific, but here's New Zealand here. Under New Zealand, the jet is pushing hard to the south, almost into Antarctica, so no support for gale development there. Let's move this off. As we get into Monday, the trough pushes east of the Southern California swell window, San Diego at about 117 west, so about right there. Once your low gets east of there, it's pretty hard to generate swell pushing due north unless you get very specific sort of conditions. The ridge continues under New Zealand. We continue on into Wednesday, ridge pushing south, no hope there. But then as we get into later Wednesday, early Thursday, 24th of April, another trough starts to develop southeast of New Zealand. But notice this, it has decent winds pushing up into it. Also note, you don't need as much wind for whatever reason in the southern hemi as you do in the northern hemi to generate gales. So 130 knot winds would do it, but this trough pretty pinched off. You want to get a broader area so you can get a good circulation going there, and just doesn't. It totally pinches off as we get into late Friday. Probably very little support for gale development. And then you get another one of these ridges starting to push south 180 hours out. So we've had what appears to be, from looking at the Hindcast model, a good run of gales that produce 30-foot or greater seas in the southern hemi. But now the pattern not looking quite as favorable. Let's go look down at the surface. Here we are, surface level pressure, surface level winds as expected, a gale in the Southeast Pacific with 30 to 35 knot winds over a broad area aimed well off to the northeast, probably getting some traction. Notice that winds actually build as we get into Sunday night at nearly 40 knots. For a brief little window, and look at that, yet another pulse even as we get into Monday evening. So some hope there. Still off in this area, really need, say, 40 knot winds, preferably 45 knot winds to generate a meaningful gale. Now we get into Wednesday, we get one of those 45 knot winds south of New Zealand on 18Z Wednesday the 23rd of April, continuing up into about Thursday morning, lifting off to the northeast. Good trajectory on that system, and then it falls apart. Another system forms due south of New Zealand on Friday, the 25th of April, with 45 knot winds, but they were all kind of aimed to the southeast, and then it pushes off to the east and fades. Here we are, nearly 180 hours out. I mean, 1, 2, 3 gales, but just not optimally configured and aimed in the right direction to really do a lot for generating meaningful swell relative to the Hawaii and the California area. All right, let's see what the effect of those winds have on the ocean surface. Here we are today, Sunday, 18Z, the 20th of April. As expected, a gale with 30, I'd say 30-foot seas here. Also note, if you're in Chile, Peru, nice little gale here, 37-foot seas aimed well off to the north. That will have no impact on, probably barely Mexico, but certainly South America. But for the U.S. mainland, no, not a hope. This is your best hope. Let's put this into motion. That gale continues as we get into Monday. Seas actually build to 34 feet on the eastern edge of the Southern California swell window. And by midday Monday, they're pretty much out of the swell window. All this, though, definitely you can actually see a swell front working its way up South America, bound the whole way up into the U.S. Continuing onward, another little gale south of New Zealand, as expected, Wednesday, the 23rd of April, with 33-foot seas lifting northeast at 35 feet. 36 feet late Wednesday night. This actually looks better. This 18Z run of the model looks better than this morning's runs of the model. So maybe some hope there. Also notice another gale here with 38-foot seas on the eastern edge of the swell window. Again, I think this is more a Chile and Peru type swell. Another gale develops under New Zealand on Friday, the 25th of April with 38-foot seas. Notice the arrows, though, aimed a little bit more southeast than northeast, so not sure how much that's going to do unless by some magic turn it starts pushing off. Good seas, though, 39.9 feet as we get into Friday night, and then fading. So we'll have to keep our eyes on that, see what the models, how they lie to us, but maybe it'll get a little bit better as we get closer to the actual development of that gale. For the North Pacific, why are we looking at this? Because, believe it or not, a gale is forecast developing off of North Japan as we get into Tuesday. About midday Tuesday, 28.6 feet and 28.8 foot seas forecast, aimed well to the southeast. Hawaii could actually, North Shore could see maybe a little bit of swell, like maybe 14, 15 second period swell, but it's a good distance away. I mean, we're talking probably like chest to shoulder high surf, something like that. Nothing particularly huge. US West Coast, just see absolutely nothing from it. It's just way too far away. And then beyond that, we're looking for anything 20 foot or higher. We see nothing, and that probably wraps it up for the North Pacific for the season. For the North Atlantic, let's see what is in store. Another little gale, 22-foot seas on Monday night into Tuesday, and continuing making good progress across the North Atlantic, likely producing some swell for Portugal and maybe into Ireland in that area. And then, but as it gets closer, it completely fades out. Put this into motion, another tiny little system, but really nothing significant forecast from that. Wind swell probably for Ireland is the best bet. On to the South Atlantic, we'll put this into motion. We would hope to be seeing some activity, 22-foot seas aimed at South Africa on Wednesday. Nothing, again, we're still looking for 30 feet or higher. And here we are almost a week out and nothing other than what we just saw. So kind of not doing so great in the Atlantic given the time of year. And then the Indian Ocean, 28-foot seas south of Australia, 28-foot seas in the central south Indian Ocean, briefly building to 30 feet, but then pretty much just getting carried by the jet quickly off to the east. That would be swell for, or background swell, I'll call it, for Western Australia and Southern Australia. Looking for something new to develop After that, 26-foot seas, nothing particularly interesting. It really seems like the balance of activity, believe it or not, has been in the Pacific, and that's kind of a first for this year, so we'll take it. Local wind forecast for California and Hawaii. California here, there's Point Conception, Southern California down here. This would be Central California, Northern California, Cape Mendocino here, San Francisco there, the Hawaiian Islands right in here. We're really looking for wind swell production, something to fill in the gaps if there isn't any southern hemi swell. And we do have that potential for California. The typical high pressure gradient, 1038 millibar high in the Gulf of Alaska, ridging up along the North California coast, tightening up the isobars, creating a pressure gradient that drives wind stronger at 20, 25, almost 30 knots. That would make wind swell all down the California coast to about Point Conception, but at a very steep angle that doesn't wrap in effectively into Southern California. That is as of right now. As we get into Monday, the exact same pattern. Now, the key here is the gradient, when it stays north of like Point Arena and stays in what I call the Cape Mendocino area, that's pretty much a typical pattern, especially for this time of year. And you don't get this, nuking northwest winds down the Central California coast. You'll still get some upwelling, but not nearly as bad as we had, was it last year or the year before, when it was, La Nina strong, the high pressure strong, the high pressure system displaced south, so the winds were nuking the whole way down to Point Conception for like 2 months. This looks more typical, as if the La Nina pattern has relaxed some. Now, you still see, as we get into Tuesday, 30-knot winds off of Point Conception. Oh, trades for the Hawaiian Islands, kind of the southerly flow, cutoff flow north of the islands. So no real support for wind swell there. As we get into Wednesday, same sort of thing. Winds back off a little bit off of Northern California, 25 knots. Got this southeast flow into the Hawaiian Islands. We're really looking for, if high pressure dips further south, then the trades, they're basically trades pushing down the California coast from the north, and they go to the east and push into the Hawaiian Islands, creating a little bit more meaningful wind swell. Now, here's where things get interesting. As we get into Wednesday and Thursday, low pressures, theoretically, this has been on and off the models, theoretically developing off the Pacific Northwest. That cuts the legs out of the high. Still, you have northwest winds at 15 knots, but not like they were. Same sort of pattern for the Hawaiian Islands. But notice the low pushing right up to the Pacific Northwest on Friday. Winds back off relative to California. The wind swell fade. No real wind swell for the Hawaiian Islands. On Saturday, the low continues off the coast. High, look at that, actually producing northwest winds for Central California, but not Northern California. It's the beginning of that trade wind pattern for the Hawaiian Islands, but doesn't get close enough to the Hawaiian Islands to likely make wind swell. This looks more like clearing high pressure from a low pressure system, from that low pressure system. Low pressure system's gone, probably moves inland, high pressure here. That's going to set up your wind machine as we get into next Sunday with 20, 25, 30-knot winds off of Point Conception, the whole Central California coast, a mess, and upwelling likely to occur. Very light trade wind pattern for the Hawaiian Islands. All right, so looking at the potential for precipitation in California. Yeah, I know, it's kind of a joke given what time of year it is now, the season has been, but we do have this low forecast off the coast. The Pacific Northwest sets up a front. Rain forecast pushing into Cape Mendocino on Friday morning. The front, you can just barely see it, maybe makes it to Point Reyes, something like that. This morning's run of the models actually had rain the whole way down to Santa Cruz, but I don't think that's going to happen. You see a little bit of hint of snow at most, the highest elevations down to south to maybe Tahoe, and that's about it on Friday night. Saturday, the whole thing clears out. That's when the northwest winds start nuking. So, yes, it was clearing high pressure. And then after that, things dry out. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley, you see from that little bit of precip, maybe 1 inch on the afternoon of the 25th of April, and that's it. No other resort. I already looked. There's no snow forecast anywhere else. We'll look at the snow levels too. Here we go. Pretty much, the red would be liquid precipitation if there were precip. The gray would be sleet. So that's about 35 to about 32 degrees. The interface of the gray and the white is the 32-degree freeze line. And then the blue is the start of 28-degree temperatures. That'd be good snow. And you see here, this is the base of Palisades Tahoe. This is the summit of the Palisades and Granite Chief at about 9,000 feet. So you see the snow level at 10,000 feet to 10,500 feet, steady for the forecast. And then when we get to, this is a 10-day window here, so the last 2 days, goes up to 12,000 feet. Say, you're going to be pretty hard-pressed to find any meaningful snow except like up at Mount Whitney or something like that. And I don't even think the front's supposed to make it down that far. So effectively, no meaningful snow. All right, so let's go look at some projected surf forecasts. We'll start up the Columbia River area up there near Portland. Wind swell in about the 4.5-foot range into Monday, dropping down to 2 to 2.5 feet. And then as we get into next weekend, wind swell picks up 7 to 8 feet sort of thing. You see some dropouts here. That's for sure wind swell, but there's also southern hemiswell forecast in the mix. Remember, there is that low pressure right off the coast. So you see winds out of the northwest. You can see the wind speeds for yourself. And then they start turning to the south as we get into Thursday and continue south into Saturday in the 20-knot range and then start fading from there. Let's go look at actual swell sizes. 4 feet at 9 seconds, some background stuff at 1/2 foot at 14 seconds as we get into Monday, Tuesday. It's all just wind swell in the 3 foot at 7 foot range. 3 feet at 7 seconds, and 2 feet at 11, 12 seconds sort of thing. Then you see bits of southern hemiswell, 0.6 at 19 seconds, 0.5 at 16 seconds, but mostly, again, 7 to 8 feet at 10 seconds sort of thing. We go down to Santa Cruz, surf heights 3.5 feet to 4 feet into the early part of the work week, then dropping off into the 2 foot range, 1.5 foot range, then theoretically coming up. But you can see the winds along the coast building as well, 2.5 feet, 4 feet, kind of jumping around. Let's go look at swell here, 3.8 feet at 10 seconds, 4 feet at 9 seconds. Little bit of southern hemiswell, 1 feet at 14 seconds. Here we go. This is on Thursday, 1.2 feet at 15 to 16 seconds. I actually think it's going to be a bit bigger than that. And so it's sort of toggling between wind swell and southern hemiswell, 1.2 feet at 17 seconds. You get the idea. Small southern hemiswell mixed with modest northwest wind swell. You go down to Southern California, same sort of deal, 1.5 foot for the early part of the work week, building to about 2.5 feet, and then toggling between 1 to 2.5 feet. Wind's not really an issue. Swell, 1 foot at 16 seconds, 1.1 feet at 17, 1.2 feet at 17 seconds, 1.6 feet at 15 seconds. So southern hemiswell dominating. There's actually more buried out in here, but it's just that the wind swell is bigger, so it gets precedence. This is only showing primary swell, and so whatever swell is more effective at whatever swell produces the largest surf gets the billing. And if there's secondary southern hemiswell, but it's not as big as the wind swell, then it doesn't get to the chart. North shore of Oahu, wind swell, easterly wind swell, whatever background swell in the 2 foot range. Whole way through the work week, then things picking up a little bit on Saturday, maybe into the 4 foot range. Let's go take a look here. Yes, 3.5 feet at 7 seconds from the northeast. Then you see that theoretic swell from off North Japan, 3 feet at 13 seconds sort of thing, and that's what gets you your 4 foot surf. That would probably, if all this happens as forecast, that will likely be the last northwest swell of the winter season of 24-25. So then we go down to Peru, just taking a look. Southern hemiswell certainly being more prevalent. Surf heights in the 8 foot range as we get into Monday, backing down to 4 feet on Wednesday, then coming up to, again, the 9 foot range on Friday and 10 to 11 foot range the whole way through the weekend. You see the swell direction here all from the That's wind direction, sorry. Here's the swell direction here. All from the south, 5 feet at 16 seconds, 4 feet at 14 seconds, and here comes the next swell, 17-second period of rise. 5.7 feet at 15 to 16 seconds, and another one at roughly 6.5 to 7 feet at 16 seconds or so. Pretty nice little pattern there. And then finally Bali. So surf height's fading on Monday from about 6 feet. Then it comes back up to nearly 9 feet on Wednesday into Thursday. And then another one on Saturday to Sunday in the 9-foot range. Swell heights 5 feet at 12 to 13 seconds, coming back up to 6 feet at 15 to 16 seconds. And that swell goes through its life cycle. Next one comes in 6.5 feet at 14 seconds. The Southern Ocean swell machine seems to be doing pretty well, even though it doesn't look particularly great on the models at the moment. Let's go take a look long-term now at the two major weather oscillations that affect our weather. That is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. So first off, we'll look at the MJO, the Madden-Julian Oscillation. There are two phases to this oscillation, the active and the inactive phase. They are effectively a low and a high pressure system that rotate around the planet, one on one side of the planet, the other on the other. They rotate around the equator, west to east. Active phase is a low pressure system. When it moves into your ocean, in this case the Pacific Ocean, it takes warm moist air down at the ocean's surface, lifts it aloft. That warm moist air hits the jet stream either in the north or the southern hemi, and then that feeds energy to the jet stream, making the jet stream stronger, make it more effective at digging out troughs and therefore building and supporting gales. The inactive phase of the jet stream does exactly the opposite. It's a high pressure system. It sets up falling air that cuts off the supply energy to the jet stream. The jet stream gets weaker and fragments and is not effective at producing gales. So the other thing is the active phase of the low pressure of the MJO. Because it is a low pressure system, what trades are produced by high pressure. If you have a average pressure that is falling driven by the active phase of the MJO, it dampens trade winds. So we can use this chart to sort of tease out where the active or inactive phase is, at least relative to the Pacific. This is data from the TAO buoy array, a series of buoys strung across the equator. Here's the equator, that's the East Pacific. That's the West Pacific. These buoys are used for monitoring El Nino, but they have wind sensors on them, so we can use them to sort of at least get a tease of an idea of what's going on with the MJO. The arrows, what we're looking at, they indicate 5-day average wind speed. So you see pretty strong easterly trades in the far East Pacific, but then they mellow out as you get towards the Central Pacific, just sort of moderate in strength. Then they rebuild over the far West Pacific. That's New Guinea there. The date line is right here. But it is not the actual wind speeds or the 5-day average winds. It is the anomaly, the difference from normal for this time of year. So you see still over in the far East Pacific, stronger than normal trades right there. But then as you get to about a point south of California, light westerly anomalies, and that sets up over the entire Central Pacific. That would be good at putting a kibosh on the last of La Nina. Then you see trades building a little bit stronger than normal here over in the West Pacific. Let's go look at the 2-week forecast. Zonal wind anomaly for the entire planet from the GFS model. Blues, purples are easterly anomalies, stronger than normal east winds. That would be roughly the inactive phase. Oranges and reds, westerly anomalies, roughly the active phase of the MJO. But this is the whole planet. Let's see if we can get the scale down there. The date line right there, right in the middle. The far West Pacific, 125 east, so right up there. The main area where the MJO has its greatest influence on the jet stream is in the West Pacific, right from the entrance to about 170 west. I call it the Kelvin wave generation area. So we've been watching with bated breath for the demise of easterly anomalies. These are really driven by La Nina. And as of the 19th, yesterday, that was likely the last pulse of really coherent easterly anomalies. You see easterly anomalies forecast to continue for, this is over the next 2 weeks, but you get the sense they're more moving off to the east, and you see westerly anomalies that have been locked solid over the maritime continent all winter long, starting just today to ease into the far west Kelvin wave generation area at about 140 east, and they're forecast to hold, if not build a little bit in coverage and also in strength. So it's the models, we've been following for months now, we've been waiting for this big dramatic transition, or at least that's the way the models teased that it would look like. Now it looks like it's going to be less dramatic, but changing nonetheless. And today is the start of that change. You see the westerly anomalies officially pushing into the West Pacific, the easterly anomalies getting shunted off to the east. Also note this here, 120 west, that's south of California. 80 west would be off of Ecuador. Easterly anomalies right here, and they've been blowing for about 10 days. That's going to be significant when we go look at the ocean temperature change over the past 10 days. Anyway, you see the good news here. That's what we're really interested in. The development of westerly anomalies in the far West Pacific and the beginning of the demise of easterly anomalies. Let's keep digging. Another component of the MJO is OLR, outgoing long wave radiation. Just fancy words for cloud cover. If you have the active phase over the Pacific and it's taking warm moist air and lifting it aloft, that warm moist air is eventually going to condense up in the atmosphere. Well, this chart basically shows you the blues, cloudier than normal skies, the oranges, clearer than normal skies. This would be condensation from rising air. This orange, that would be falling air with no moisture associated with it. So active phase of the MJO, inactive phase, and South America, Central America, New Guinea, the equator, EQ right there, the date line right there. So active phase starting to build exactly where we'd want it to be in the far West Pacific. Per the statistic model, this is a statistic model, the CA model, that holding on day 5, fading some on day 10, and then the inactive MJO setting up 2 weeks from now. Now, the GEFS model paints a different picture and has been steadily painting that different picture for the past 2 weeks now. Active phase, holding. No surprise, if you have westerly anomalies, well, there's 125 east right there, and they're building to about 140, maybe even 150 east. That would be a clear indication that the active phase of the MJO is pushing into the West Pacific over the next 2 weeks. So there's the statistic model. There's the dynamic model 2 weeks out. I like what the dynamic model is telling me. This is a much better picture. This would help feed the Jetstream and help support gale development in the southern hemi. Phase diagrams for the same two models, statistic model here, dynamic model here. What do these charts tell you? They tell you where the active phase is and how strong it is. The MJO moves from west to east, from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is, so right smack in the center of the West Pacific. The closer that dot is to the circle, the weaker it is. So a weak active phase. Per the statistic model, 3 different members all have it. The active phase moving to Africa 2 weeks from now and very weak, where the dynamic model has it trying to go to the East Pacific and then retrograding back into the West Pacific 2 weeks from now, but exceedingly weak. Upper level moisture charts, okay? South America, New Guinea there, 0 is the equator, date line roughly running right down here. This goes out 40 days. Each panel is 5 days long. The greens area is favorable for precipitation. Again, that upward moving air, active phase of the MJO. Also notice the dry air, the downward, the inactive phase of the MJO here. Remember, we saw easterly anomalies in this area from the GFS model, and this model basically is saying the same thing. Now, the interesting part about it, all these models are they're saying the active phase is hanging here, and it's not moving a whole lot. Normally it takes like 4 to 5 weeks for the active phase of the MJO to make it across the Pacific. Well, this active phase has been sitting here for probably the past at least 4 weeks, if not longer, and has not, every week we do the video, it's just sitting in the exact same place. So the MJO is not moving very much and doesn't seem to be predisposed to doing that. That's kind of a good thing if you're trying to wipe out La Nina. That is the low pressure bias, we'll get into this in a minute, which all winter has been over this area, is very, very slowly trying to ease its way into the West Pacific. Anyway, active phase of the MJO, at least according to this, if you believe it, holding in the Pacific till the 5th of May. Based on the speed that things are going, I'm betting it's going to be at least the middle of May, if not longer. But then theoretically, inactive phase shows up mid-May and takes over the Pacific after that as the active phase moves over the East Pacific. We'll see how long, basically the MJO is stalled right now, according to this model. We'll see how long it takes to become unstuck. Next up, the CFS model, another dynamic model showing 850 millibar zonal wind anomalies. So those are winds up about 4,700 feet, but a pretty good proxy for what's going on down at the ocean surface. Dateline runs right up the middle. The far West Pacific starts 125 east right here. This is what's been going on. This has the MJO on it too. The black contour solid, active phase, the dotted black contour inactive phase. You see perpetual easterly anomalies driven by La Nina. No MJO signal after about March 22nd. Here we are today. You see the easterly anomalies, and here's the westerly anomalies pushing into the far West Pacific. They're going to make a little backward turn in about 5 days, but then westerly anomalies continue making it to about 150 east, filling half the Kelvin wave generation area, and steadily building while easterly anomalies steadily collapse. And you see this, they really are moving off to the east as we get into the first week of May, and that pretty much should be the demise of La Nina. And then finally, the CFS model going out 3 months. This depiction of it shows past performance here, the future here. You can clearly see, and the date line runs right up the middle. Far West Pacific starts at 125 east, so right here. You can see the dominance of easterly anomalies, every pulse of the inactive phase of the MJO. Here we are today, the last of the real easterly anomalies on the date line, maybe holding for a day or two. And here's your westerly anomalies. Now they are in the West Pacific, and you get this kind of neutral pattern, almost making it to the date line. One last little pulse maybe of easterly anomalies at the end of April, but that lasting only for 3 or 4 days. And then look at this, westerly anomalies fully taking over the Kelvin wave generation and holding from there. So look at the flip here between easterly anomalies in control over the date line and westerly anomalies in control of the date line. This suggests the total demise of La Nina here, and not the development of El Nino, but the development of just kind of a normal kind of pattern. Let's overlay the MJO here. Let's see what's going on. So there is a weak little inactive phase of the MJO, pretty much exiting the Kelvin wave generation area, and in a day, supposedly, the active phase of the MJO, weak as it may be, starts building over not just the Kelvin wave generation area, but over the Equatorial Pacific, the whole way to a point south of California. Westerly anomalies building with it, being dragged over the date line, all that holding till first part of June. Inactive phase is forecast after that, but notice westerly anomalies holding. And then another active phase as we get later into June, all the way into July, with moderate westerly anomalies over the Kelvin wave generation areas. Certainly an absolute change of pattern between this and this, with easterly anomalies, now westerly anomalies. We overlay the low pass filter. Here we go. This dotted contour, this is your La Nina signal. It's high pressure bias over the date line with 1, 2, 3 contours. Third contour, forecast fading about a week from now. So maybe next Sunday when we do our video, we'll hopefully we'll be able to report that La Nina is in full retreat with the second contour fading out middle to late May, and then the final high pressure bias east of the dateline by the first week of June. Notice the low pressure bias here, which has been over the maritime continent, starts easing in. I actually did this today, and right about here, right about May 10th or so, is when the isobars starting to seriously move into the West Pacific, and then fully in as you get into the first week of June and beyond, reaching the whole way to the dateline by the end of the model run. Now, maybe this is a bit aggressive because, when was that? 3 months ago, the westerly anomalies were supposed to die on March 24th. You see, here we are. They're just now starting to do it. So they're about a month behind schedule. And that sort of speaks to what we saw in that other chart where the low pressure or the active phase of the MJO and the upper levels of the atmosphere is just like stalled, waiting, trying to get into the West Pacific. We think it's coming. Everything says it is. And we're getting some evidence that easterly anomalies are going to be dying. I mean, even in the next 2 or 3 days, at worst, we should see a significant change. So it seems that we are at the transition point as of about now. So what does the ocean think is going on? We're looking at data from the TAO buoy array, but this time we're not looking at winds above the ocean surface. We're looking at water temperatures down in the ocean surface. Here's the anchor lines. The X's are the sensors on those anchor lines for each of the buoys. They collect water temperature data, use a model to fill in the gap. 29 degree isotherm. I think it was over at 167, so it's retreated just a little bit, but the 28 degree isotherm last week, I think it was at 178. It is now the whole way to 174 west, so it's making some headway. 24 degree isotherm the whole way across the Pacific, 28 degree isotherm also in the far east Pacific. This looks good. Next chart looks even a lot better. This is showing, now we've been seeing this warm water in the west, 2 degrees above normal. Warm water in the east, 3 degrees above normal. There was a gap here where cold water was all up in this area. Now, all of a sudden, look at this. 0 degree to not 1 degree, but neutral temperatures basically the whole way across the Equatorial Pacific. There is this pocket of 2 degree below normal anomalies here, but it's now cut off from pretty much everything, at least according to this set of data. Let's go look at some other data. Now, this is the same set of data, TAO data, buoy data, but also with satellite data overlaid on top of it to get you a profile of what's going on subsurface-wise. But notice, this is from the 13th. That other data we just looked at was from the 19th. You see the finger of warm water here. You see the finger of warm water there. You see the cool water all but just barely hanging on. It wouldn't take much of a leap of faith or much of anything for warm water to stretch across here. And then you've got basically the same picture. When this thing updates, maybe even as early as tomorrow, we'll see if it picks up on the same thing. But the other thing here is this model was showing, there's one shade of blue, 0 to half a degree, but it was showing half to 1 degree and even more last week. And now the half a degree to 1 degree temperatures below normal are getting smaller and smaller and smaller, basically suggesting the complete collapse of La Nina from a water temperature perspective. And that is super key. Okay, if the water temperatures collapse, if you have colder than normal water, that doesn't support evaporation. That supports high pressure development in the Equatorial Pacific. But if you have what they call neutral water temperatures or even warming water temperatures, then you start getting evaporation. When you get evaporation, then you get air moving around, and that is not conducive to high pressure development. Rising air from evaporation is conducive to low pressure development, and that would be what we'd expect to see in ENSO neutral conditions in here. Again, I think we're right on the cusp. Here is the satellite data. Again, this is from April 13th. Here is the equator right here. Ecuador would be there. Chile and Peru down here. Central America there. Hawaii right up here. Dateline right there, and New Guinea over here. These are not temperatures. This is the height of the sphere of the ocean. Take the waves, wind waves out, the tides, and is the sphere higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts. When it contracts, you'll get a divot on the ocean surface. Water is displaced downward. Likewise, if you have warm water at depth, it expands. When it expands, it pushes the surface water up above it. Get a bump on the ocean surface. So here off of Ecuador, there was warming temperatures, and you see subsurface, or at the surface, the ocean surface height was above normal. Okay, going the whole way out to, where is that? About 150 west, south of Hawaii. It's just we'll say 5 degrees north and south of the equator that matter, but really the last of the negative anomalies from La Nina are here south of Hawaii, minus 20 centimeters, minus 15 centimeters, and they are steadily fading. Warm water, though, still mainly sequestered up here north of New Guinea from stronger than normal trades that have been blowing all winter long. But like everything weather-related, it is the trend over time that you can really see how things are going on. So this is the West Pacific here. This is the East Pacific here. Upper ocean heat anomalies. Blues, colder than normal temperatures. Yellows, reds, warmer than normal temperatures. La Nina is characterized or hallmarked by colder than normal water off Ecuador. So that's right where this is. And El Nino is characterized by warmer than normal water, not in the West Pacific, but over here. But you see the trend, colder, or cold, warming here, starting to encroach more off to the east. Now, the other thing I was telling you all was cold water Kelvin waves. It's really the upwelling phase of the Kelvin wave cycle, but I didn't really focus that. There were actually warm water Kelvin waves. They just weren't making it very far. One there. Then here's the upwelling phase, cold water. Another warm water Kelvin wave in August of last year, upwelling phase. You can clearly see that the upwelling phases are stronger than the downwelling warm phases. Okay, and that's the hallmark of La Nina. What we are looking for is at least a transition to where the warm water Kelvin waves and the resulting upwelling phase after that are of equal proportions. Notice the buildup of warm water here in the far West Pacific. Pretty impressive. And now the arrival of warm water here almost looks like some sort of a Kelvin wave broke through here in the March time frame. And then the next piece of the puzzle, what are sea surface temperature anomalies doing? Is the sea surface temperature warmer than normal? And really what they look at is they call it the Nino 3.4 region. Nino 1.2, so here's the equator right here, South America, Central America, Hawaii up there, New Guinea there, date line running right there. Nino 1, there's different areas they use for measuring water temperature anomalies on the equator. 5 degrees north and south of the equator. Nino 1.2 is right here. You see the warming anomalies, but now you see cooling here along the coast of Peru and this new little finger of cooling here. When I said there was easterly anomalies in this area earlier in the presentation, inactive phase of the MJO likely somewhere over in here, creating easterly anomalies, and that is what is happening. It's taking a hit of what was a really warm pool right here. We were almost going like, oh, looks like El Nino, but it wasn't, of course. And so now it's getting eroded some. But here is the last remnants of La Nina. And it pretty much goes from about, the Nino 3.4 region is from 120 west, 5 degrees north and south of the equator out to about here. You still see, now I'm not even going to look at this for a second. It's really out here. This was our Madoka. This is the cool pool that exists, and you see it's nearly neutral everywhere except here at 150. This cooling up here is this typical springtime high-pressure system that sets up the nuking northwest winds down the California coast, create upwelling, and then that wraps around the high, which is pretty much right there, creating upwelling out to the equatorial central Pacific. But the official, or the real La Nina cool pool, which out here, is almost looking to be gone. Not warming temperatures, but the last little remnants of cooling barely hanging on and pretty much a neutral pattern setting up. Here is the trend, sea surface temperature, water temperature trend for the past 7 days. I almost titled the video, what was it? That wasn't expected. Look at that. I mean, that looks like raging La Nina, but that's not actual water temperature. It's just the difference in water temperature for the past 7 days. Clearly, you see off of Ecuador, temperatures cooling. In fact, one of our viewers lives in Ecuador, and he wrote and he posted on last week's video and said, yeah, temperatures are dropping dramatically here in this area. Rainfall is abating because the temperatures are getting colder, right? You don't have the evaporation. And it's probably turning more towards what is normal for this time of year. I mean, it's pretty normal to get high pressure going right off here. That sets up upwelling along the coast of northern Chile and certainly Peru and off of Ecuador. This is a pretty broad expanse of cooling, but we also noticed easterly anomalies in this area. I think it's attributed to the inactive phase of the MJO hanging over this area. Active phase over here. So as the active phase moves this way, the inactive phase will move into the Atlantic, and then this will return to kind of more of a normal regime. In the official El Nino monitoring region, Nino 3.4 from 120 west out to about 170 west, you see a generalized light warming trend. And as one would expect, this is sea surface temperature. You can see actual temperature trend in the Nino 1.2 region. While we were up there in the early part of April to almost 1.5 degrees above normal, crashing today. Yes, it's getting colder, but still, it's 71 thousandths of a degree above normal. So we're just down to normal temperatures, at least for 1 day here in the Nino 1.2 region. But in the official El Nino monitoring region out there, temperatures 180 thousandths of a degree below normal. So 0.2 of a degree below normal. And so neutral is 0.5 degree above to 0.5 degree below. If you're in El Nino, you have to be above 0.5 degree for a weak El Nino to +1, and for a medium from +1 to +1.5. Same thing going La Nina wise. 0.5 degree to 1 degree is a weak La Nina, and moderate from 1 to 1.5. This La Nina pretty much was weak the entire winter, and now it appears we are heading towards neutral. Weekly adjusted sea surface temperatures in the Nino 3.4 region right here for the week of April 9th, -0.1 of a degree. The week before that, -0.1 of a degree. The week before that, +0.2 of a degree. You get the idea. Just toggling since late February, pretty much right around dead neutral. And finally, what does the atmosphere think is going on? We have cool temperatures, but they're warming in the equatorial Pacific to almost neutral. And then once that stabilizes for a while, the atmosphere will pick up on it and start making changes, and pressure theoretically should start falling over the equatorial Pacific. Now, recall, we are only really a week or two into some sort of a neutral temperature change in the equatorial Pacific. So I don't expect the atmosphere above that. I mean, it's going to need a couple of months to really start significantly changing. But anyway, we have this set of data from surface level pressure in Tahiti, surface level pressure, and that's in the Pacific, Darwin, roughly in the Indian Ocean or maritime continent. When pressure is lower in Tahiti, the index goes negative. Well, today it's 11.10. No big surprise. You see, we're actually negative for a couple of days there, but that could easily just have been attributed to low pressure over Tahiti. All right, and you go back in time, well, eyeballing this, kind of looks like maybe the numbers are trying to trend downward. 30-day average, well, it's at 7.94, so still in weak La Nina territory. Where were we a month ago? 6.12, so really no change, but the MJO definitely affects these numbers. Then finally, the 90-day average, this is your La Nina El Nino indicator, plus 8.15. Still weak La Nina, where we were at plus 5.02 a month ago. But again, remember, this was a late forming La Nina. It didn't even really peak till, what was that, end of January, mid-February even? So it's not, and this is a 90-day average, so it's not surprising that this is a little bit on the high side. I would expect that this will start falling, but it might take 30 days after it actually starts falling to become noticeable here. So we look at this, but we're also going to look at those, really, I'm focusing on westerly anomalies over the West Pacific as being a good indicator that the change is happening. Also, here is a graph of what's going on. You see here's the 30-day average. The main graph that we normally show, it hasn't been updating, so I'm just ignoring it for now. But 0.7 is, or 7 of value of +7 to -7. The Bureau of Meteorology in Australia considers to be neutral, so just barely in weak La Nina territory. And also outgoing long-wave radiation anomalies. Again, if you have warmer water, you get condensation, you get more clouds, right? So here is the date line running right here. These positive anomalies, we've been in La Nina, water's been colder than normal, trades have been stronger than normal, so this is drier than normal air. You see it peaked in late February, early March, but now look at it. It's, I would say, significantly collapsing. And here is the cloudier skies right poised to come into the Pacific. And the expectation is that somewhere in the next month or two, these are basically going to flip, maybe 3 months. But these blue anomalies are going to start working their way into the West Pacific. They're already there. There's 125 east right there. So they're already there, but they're going to become more substantial as westerly anomalies build here over the dateline. And then finally, sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region. Where are we today? Oh, that's April 15th. So we're out here somewhere. Temperatures 1/10 of a degree below normal. Basically going dead neutral as we get into June, holding there the whole way through the fall into about December, and then starting to rise into January. Still in 1/2 degree above to 1/2 degree below normal is considered neutral. So basically dead neutral. There's another version of it here, PDF corrected version. It's showing about the same thing, give or take a 1/10 of a degree. So basically for this coming fall, dead neutral ENSO conditions. All right, so let's go take a look at the immediate picture. Series of gales have traversed the southern hemi. None of them super ideal, none of them huge, none of them pushing super hard to the northeast, but all capable of producing rideable, fun-sized southern hemi swell for probably the next 2 weeks, starting somewhere, I think Hawaii maybe on Monday, and here into California on Tuesday, and then steadily building up as we get into the weekend, and then the whole week beyond that as well. So a good run of fun-sized southern hemi swell is coming. A little bit of a pause, it looks like, after that, but conditions in general seem favorable as the active phase of the MJO, as it moves a little bit more into the West Pacific over the coming 2 weeks. Hopefully that's what it does. West anomalies build on the dateline. That will feed the Jetstream. We'll get more southern hemi action. Nothing over the top, but kind of just, it looks like we're setting up for a real neutral summer. Is that good or bad? I don't know. Let me know what you think. I'm thinking that it'll be better than having La Nina, at least. We'll see. And hopefully the northwest winds along the California coast stay, for the most part, in the moderate category and stay mainly up by Cape Mendocino. That would be good. So the water temperatures warm up some. They're not horrible right now, not like last year, but a little bit warmer would always be better. Hawaii trades pretty light for the whole week. And not as much southern hemi swell, but background southern hemi swell, and maybe one last push of northwest swell. I think it was, Friday and Saturday for the North Shore of Oahu. Then after that, things go pretty quiet, and we're fully in summertime mode. Looking long term, looks like ENSO neutral the whole way through fall and winter. I think that will be a good thing. I'm hoping it will not be a bad thing. Sometimes you get this thing where you get ENSO neutral and there's just no momentum in the atmosphere at all, and then you don't get a good storm track. It seems like when the pattern, the El Nino pattern or ENSO pattern is swinging hard one way or the other, you get a little bit more momentum, but I don't know. We'll just have to see on this one. Kind of hard to tell. But in general, neutral is better than cold. I'll take whatever I can get, and I think you would too. All right, so that's our video for this week. Again, happy Easter. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. And if you'd like to make a contribution to the cause, you may hit the super thanks button down below the heart with the $sign in it. And with that, we are done for this evening. We will do it again next week, same time, same channel. Thanks so much for watching.